Hi everyone. Today we start lecture number 2 of structure analysis. We discuss question on double integration method. In lecture number 1 we discuss double integration method, and in lecture number 2 we solve the question on double integration method. Here question is, a cantilever beam of length L is subjected to a point load W at its free end. Define the value of slope and deflection by double integration method, taking the EI of the member. This is the beam. At the end of beam, we applied any load W as our statement. Here any strain L. So students, tell me which type of beam? Cantilever beam. Here one end is fixed and other end is free. At the free end, any load W is applied. So here we find the theta and delta B. Theta A and delta B. B मतलब at A and B. As per discussing video number 1, lecture number 1, according to the curvature equation, EI d square y by dx square equal to mx. This is positive sign. It's not necessary to mention, so you can not mention it. So in this equation, important parameter is mx. So mx is found at any section xx of this beam at a distance L minus x from the end B. B is the descent. A is the descent. From the end B, we find the moment at section xx. Right. You can easily find out mx about this section. If we taking a moment of this load about this section, so what is the moment? Load into perpendicular distance. So this is the load W multiplied by perpendicular distance. What will be the perpendicular distance? L minus x. So mx equal to minus WL minus x. Here is the W. Here is the mx is showing the hogging moment. How you know? If you taking a moment about this section, the upper reference of this beam is shaped as hogging. right? Like this. If taking a moment of this beam section, what XX section, so this beam upper surface look like a fogging, right? So it will be taken as a negative. Make with negative sign minus W L minus X. Here you find the mx. Mx value put in curvature equation EI d square y dx square equal to mx. Put value of mx minus W L minus X. Another step is taking a integration both sides of this equation EI dy by dx equal to minus W here Lx minus x square by 2 and adding a constant, any constant C 1, right? Here we see for cantilever beam, first condition is x, if we put x equal to 0, dy by dx equal to 0. Mean at a distance x equal to 0, our slope will be 0. Dear students, we know that at a fixed end, of a beam, here not be any slope and deflection. That's why dy by dx equal to 0 and y equal to 0 at a distance x equal to 0. X will be start from here. So if we put x equal to 0, slope and deflection both are 0. Here both conditions x equal to 0, dy by dx equal to 0. Second condition, if x equal to 0, y equal to 0. So these first condition applied for equation, for this equation to find the constant C1. If we put the x equal to 0 there, dy by dx equal to 0, that's we find the C1 equal to 0. Next, if we integrate of this equation, this is the equation number 1. Once again, EIYY equal to minus W Lx square by 2 minus x cube by 6 plus C2. Here, this equation is called deflection equation, and this above equation is called slope equation. This equation is the slope equation. We applied condition 2 to find the value of constant C2. If we put in this equation x equal to 0, here y also be 0. So easily we find the C2. C2 value put in equation. In this equation, here we find the deflection. Here we find the deflection equation in term of this. Here E I by y equal to minus W Lx square by 2 minus x cube by 6. Here put C2 equal to 0. That is equation 2, deflection equation. In a question, we find the deflection and slope at A and B. At A and B mean x equal to L. Here we find the slope and deflection, right? So now slope at V x equal to L. Here theta B equal to dy by dx modulus equal to WL square by 2EI. So here we put the in slope equation, equation number 1, we put x equal to L. Here we put x equal to L. From equation 1 we derive theta B easily. Here theta B equal to WL square by 2EI. Right. Same value of x equal to L put in deflection equation. Equation number 2. Here we find the deflection WL cube EI. This is our question. Solve yourself. If any problem, ask me. Very easy question. At least 15 marks. 15 to 10 marks will be given you a MDU exams. Now we start with second question. A cantilever beam length L is subjected to uniform distributed load W per unit length over an entire span, where the expression for slope and deflection at free end point at double integration method. Solution of this question is, this is the question. All cross span is applied uniform distributed load W. Here we find the theta B and delta at A and B at a free end. As per previous question, same step will be followed. We said that first we utilize the curvature equation. Curvature equation is EI d square y by dx square equal to mx. Here we find the mx, moment about any section xx. So we find the moment of uniform distributed load. What is the moment? Load into perpendicular distance. So here is the load. It is act as a hogging. So take a negative sign. W into distance, where we find the moment of this section, we find the moment. So multiply by this distance, W into L minus X, multiply by distance divided by 2. As we know, if we find the uniform distributed load moment, we multiply load into distance by 2, right? So WL minus X, L minus X by 2. Here is bending moment is minus W L minus X square by 2. mx value put in equation 1, ei d square y dx square minus w lx l minus x square by 2. Integrate this equation with respect to x, ei dy by dx equal to, here 2 comes out to bracket, which will be constant, minus L minus x cube divided by 3 plus adding constant C1. Apply limit to find the constant C1 when x equal to 0, here dy by dx equal to 0. Here we find the C1 minus WL cube by 6. Put C1 value in this equation. Here we get, here we got slope equation. ei dy by dx equal to w by 2 bracket minus L minus x cube by 3 bracket plus minus WL cube by 6. We put value of C1. That's given equation number 2. Once again integrate equation 2 with respect to x to find the deflection. ei y equal to minus w by 2 L minus x 4 divided by power 4 plus C2 minus WL cube by 6. Here we put the value of x equal to 0 and y equal to 0. The value of C2 WL4 divided by 24. Put C2 in equation 3 in this equation. Put C2 in equation 3, ei equal to minus w by 2 bracket L minus x power 4 divided by 4 bracket plus WL4 divided by 24 minus WL cube by 6. By applying the limit x equal to L in equation 2 and 3, we easily find the value of theta b and delta b. Theta b equal to dy by dx at limit x equal to L. The value will find WL cube by 6 EI. And delta b deflection at limit x equal to L equal WL by 4 divided by 8 EI. I hope all are you understand well. As per assignment, you can solve same question. You can solve same question. If we put uniform varying load UVL, if we put uniform varying load on this beam, uniform varying load will be vary B to A, means at B it equal to 0, at A it will be maximum, like this one. Mean at A it will be maximum and at B it will be 0. Same step will be followed for solving this question. Only mx value will be changed. So taking mx at any section xx and find the constant c1, c2. Put constant value in slope equation and integration equation, slope equation and deflection equation, and find the value of the slope and deflection. Putting the x equal to L, we easily find slope and deflection, right? If any queries, you can discuss me on my email ID Parveen Parvn Parveen ANSHINC @gmail.com. Thank you guys.